So I have a file node here with my root version. I'm using it for the cloud renderer, but actually you don't need to use that because I've locked the file inside the scene file. So no matter what, you will get it there. An assemble to create a name attribute over the primitive. So let's see what we have. Let's take off the stat. And those are the amphora. I've placed it like a bit randomly. Sometimes we have some collisions, but those are static, so it's not a problem. It works when the camera is there. Okay. Good. After, I wanted to make it explode, but not all of them, just four of them. So this one, this one, this one, and this one. That's why I've created a group. If I check it here, those four. All right. So now I have group. I've decided as well to rename the group inside, because when I'm going to fracture it with the RBD material fracture or other ways, I'm going to create an inside layer as well, and then I will lose the original one. If we check the original inside layer, group, sorry, there, primitive, let's refresh it, and as you can see, this is the interior of the amphoras. So I want to keep this information. That's why I've renamed it here inside to inside O for inside original. And this is what I'm saying here. Once it's done, I just split the amphora that I want to explode. And let's maximize it. Refresh the name attribute here to get 4 different unique, even though it was the same there, but not in the same, let's say the correct way, the correct name. So I got 3, I got here, I got 7, 6, 4, 3, and now I have 0, 1, 2, 3. I've decided as well to add an ID, name ID attribute here, as you can see, from the digit of the name attribute, which is, if I go there, name ID, so I get 0, 1, 2, 3. Let's sort it, 0, 3, 2, 1, 0. I've done that because I'm going to do some operation, to apply some operations, and then I don't want each time to say, hey, this is the amphora 0. I just want to say 0, 1, 2, or 3. It's easier and faster. And that's why I'm saying here. So let's dive there and check the first RBD material fracture. All right. Let's see what we have. Nothing particular. I want to refresh maybe. Yeah, that's better. And here I just have like primary fracture, just one level. And inside the detail, I'm using as well the noise to get some variation, like this one and this one, and that's it. I'm okay with that, but I would like a bit more detail in terms of fragmentation, especially on the edge. So that's why I'm doing another level of fragmentation. But just before, I used to set a divide node to prevent some problem during the second fragmentation. Sometimes you might have some problems, so it might help. So let's go inside the for each. And this is the result. Let's see. Okay. So as you can see now, it's fragmented on the edge. And we are going to check how we have done that. Let's refresh like this. Okay. And the way to do that is just if we isolate a single pass, let's say U or U maybe. Yeah, maybe U. Okay. and let's check what we have. Okay, so first of all, this is my fragment, and I want to select the edges to fracture it. And this is what I'm doing here, set by the blasting the inside, I mean the opposite of inside, so the outside group. But I don't want to get a fragmentation over all the edges, just one side, let's say, or just a part. Because if I was doing the fragmentation around the full up fragment, instead of having here, or actually that's a bad example, let's go back on the full one. So I was saying, if instead of having here just up one cut or one fragment, I will get twice, and actually that's not realistic. Same thing here, same thing here. So I have to say inside the for each that I don't want the full edges, but just one part. And there is a way to do that by computing the normal. So let's see that this is my normals, and I'm going to delete it from a dot product. Let's see the code. So you have to specify a vector, no matter what is it. Actually, I could change it, it would work, even though I will get a different result. And then using a dot product here, and say if it's inferior than 0, then remove the point. So this is what we have. What does it mean? It means that, for example, for this part, if my normals are going this way, then it's going to be good. I'm going to keep it. But this is actually the seam between another fragment. So you have to imagine that the other normal from the other fragment, this one, let's say, will be on the opposite way, right? And by specifying a vector like this, I'm using a reference. Like if I accept this direction, then the opposite direction, I will delete it. This is when what I'm saying with by inferior than 0. Not sure it's very clear or accurate what I'm saying, but if it's not, just try and you will see that's a nice way. Alright, so sometime with this way I've get some bad points like this, so I just clean it, and then it's a bit better. Some scatter, because I'm going to create a mesh from points to use as a boolean to get my fragmentation. So a bit of variation. Let's see the color like this. This is an attribute noise, and then you can change whatever you want. Then blasting it like this to get more variation. Then a particle free surface to mesh it, a remesh to make it cleaner, an attribute blur to prevent some bad intersection or whatever, a mountain to add a bit more variation, the normal, and the divide. We never know. It might help to prevent, even in this case I don't think it's necessary, but it might help to prevent some problem with the boolean. Alright, here I'm using solid and the shatter operation. By the way, I'm creating two different groups. The B inside A first, B inside A first, and the A pieces. I'm not sure actually that I will need those, but just in case I prefer to add it. We never know. And I'm copying the attribute name ID, because with this operation I'm creating new geometry, and this geometry doesn't have the name ID attribute. And that's it. So let's go there and see if we are okay with what we have. Alright. Yeah, it's better. But actually, when it's going to explode, I don't want to get that kind of things. It has to be way more detailed and way more fragmented. So that's why I'm going to split again those parts with the main fragments. So let's go there. Here it's just an update for all the fragment name attributes. And then I split the A pieces group, which is the one that I've created here. So this is useful, and I want to say that those fragments are way too big, and that's why we are going to add another level of fragmentation. So first of all, let's get a measure. We want to get the volume, because first of all, for example, we don't want to fragment this one, or the small objects, the small fragments, like those. So let's isolate it. And as you can see, yeah, we don't want to fragment those. So let's go just there and see what we have. Actually, up, not you. Let's go there with everything. So this is just a merge with the small fragments and the other level of fragmentation. I've added an assemble to update the name attribute, and I've just set infra details because I wanted. And this is the result of the fragmentation. And yeah, this is way better in my opinion. I could go higher, but I think it's alright. So let's check the way of fragmentation. This time, let's actually isolate one layer, one fragment. And let's take this one. Okay. So the way that I'm doing that is just same thing, blasting the inside to isolate it, or yeah, I'm isolating it. Using a scatter to get some point and then copy a sphere into it, but it's a bit too much there, so I'm going to fuse it to get like something consistent in terms of point numbers. I could reduce here the number, but I don't want to do that because I'm not sure for the other fragment if it's bigger or not, and then I prefer to set a lot of points and reduce by distance, so I will get the same overall density of fragment points. Here I'm adding two different attributes from an attribute randomize, the p-scale and the orient, just to get a different orientation for my sphere and a different scale for the sphere as well when I'm going to copy it. Like this. So if I don't do that, it's the same, difficult to stay there. And maybe if I take out down. So let's decrease this one. Yeah, as you can see, this is the same orientation. So let's go back to 1 and go back this one, set back this one. And the p-scale, same thing, using a custom ramp that I fit at the minimum to 0.25 to get overall the result that I want. So yeah, that's good to me. This way seems to be very unpredictable, but actually it's very fast, and I like the kind of shape it creates. And actually it's a bit more stable than the grid, I mean, in my opinion. So I'm using it quite a lot for different cases. But yeah, the thing that you have to specify here is just to use as well a solid with the shader. Same thing, B inside A second, which is my second fracture level, with the Boolean operation, and A pieces. Alright, let's copy as well the name ID attribute and see what we have. Yeah, let's actually take out this one. Yeah, this is the result of the fragmentation, which is okay. Where is it? It's not even visible, is it? No? Ah yeah, it's there. Yeah, it's good to me. So let's set back this one and this one and see the result from the camera. Yeah, this level of detail is good. Maybe a bit more will be even better, but it's up to you. So let's check the other way. So here I have the main fragment, those one, okay, and then I decide to get another fracture level from it, because I would like to make it break when it's colliding with maybe the amphora or maybe the ground. And this is why I'm adding here the RPG material fracture. Alright. And I get this result. Nothing special inside, just one fracture level, the detail, and the constraint. I set back the primary strand to 1. So now I have this constraint, which is good. And let's clean it, because you might get some point that you don't want. I call it constraint, even though I think there is already something. Yeah, constraint name, but yeah, up to you. And then merging everything together. So this is what I have. Okay. Alright. The amphora fragmentation detail, the main fragments, and my constraint. Alright, so let's split the constraint and isolate it just there, add constraint. And here get all the fragments. Here I'm using the convex decomposition because sometimes, for example, here on this area or there, if the fragment is too big, then the collision is going to be not really accurate. So that's why here I prefer to use the convex decomposition. Let's keep this one for now. I will go back to this just after. And here, packing everything, I will go back after to this one. Same thing for this one. And here I have my packed fragment 713 that I'm going to simulate. Alright, here I have my constraints. And here, this is my high-res output. So I've just decided to combine all the different group elements that I've done. So I create a new one called inside G for inside global, and this group is equal to the inside group that already exists, to the B inside A first and B inside A second. I'm using this group to create new UV over the vertices and with a cylindrical way, and then apply two different materials, one on everything and the second one just on inside O. I could use inside G as well. It's not really important in this case. But the main difference between those different materials, let's say, this is the drawing. There is no drawing or painting. And this is what I wanted. Because if I turn off this one, for example, let's delete it. As you can see now, everything is applied from the first material, and I have some drawing inside. And I don't want that. So the texture are a bit different there. Okay,